In this video, we are going to go over how to mesh and perform a linear statics analysis on the stiffened plate. Now, to get started, let's go ahead and undo that. Let's go to File, Import, Geometry. Let's go ahead and select the parasolid file that contains this geometry. Now, I'll show you the number one wrong way of doing this. If you go to the meshing tool and go and click solid mesh, the worst way to do this is by meshing this with tetrahedral elements. So let's go ahead and use that meshing option. If you use tetrahedral elements when you have thin walls, this is the worst way to perform the analysis. So in this video, I'm going to show you how to perform a statics analysis using 2D elements, which is the common and preferred method. And then towards the end of the video, I'll show you how to do this with 3D elements, which is something you would rarely do, but some users do use 3D elements. So I'll show you how to properly use 3D elements later on in this video. So let me go ahead and undo this mesh. Here in the model browser, open the part 1 branch, and so far we are working with this solid geometry. If you go to geometry edit tools, here in the bottom right, there's a mid-surface tool. Let's go ahead and click that option, and this opens a new window. Here what you can do is you can click on faces on the thin wall structure, and this will automatically create surfaces at the midplane of the walls. So here we can go ahead and click these different faces. Now you can go face by face, or you can use the different options. So let's go ahead and undo all of these faces. There are faster options. So right now we're using the auto offset option, which is this button. Let's go ahead and use this other option. So let's go ahead and click that option, click this body. And now this will go ahead and automatically create the properties for you. And now here, let's go ahead and undo that. And let's use this third option, fix distance face offset. Let's go ahead and look at this. Okay, maybe that's the option I want to use. So let's go ahead and close this. One thing you'll notice here on the left, let's go ahead and right click the solid and hide it. You can hide and show objects by clicking these individual checkboxes. I'm not a big fan of these checkboxes. I think these are honestly not optimal designed. So here, let's go ahead and select multiple rows and show them. Right click on these objects and either hide or show them. I like using the right click option to hide and show. The checkboxes are not something I like to do. Here, let's go ahead and select the vertex edge drag tool. You'll notice that here, if you orient this, there are actually gaps between these faces. With the vertex edge drag tool, you can just select a edge or vertex. You can move it. This will connect the edge with any adjacent face. So here you'll notice that these two edges are connected because the edge is now yellow. And we can do this with the other edges. So you notice I can drag this edge here, or I can drag it until this face. So here, let's go ahead and drag these edges. So now these three edges are connected, if you will. Let's go ahead and undo that because there are other options too. Extend surfaces. So here you can use an extend surface option. Here, let's go ahead and measure the distance between these two gaps, or this gap rather. So let's go ahead and click that point in this face. It's 50 millimeters. So here at the top right, there is a measure distance option that will give me the ability to measure distances between vertices, edges, and faces. So we know that's 50 millimeters. Let's go back to geometry, edit, extend surfaces. Here I want to use at least 51 millimeters, something slightly greater than that gap. So let's go ahead and select all these different faces, and this will go ahead and extend the faces and we'll stitch them together so the edges are shared and all are connected. Here, there's another way of doing this. Deselect the lightning bolt tool. So this disables the automatic execution of the tool. So here we're still in the tool, select the bodies or the objects. Now it's up to you to decide when to perform the execution. Here, the way to execute this is by clicking the scroll wheel, the middle mouse button, or MMB, and now it executes the action. So there's a difference between the lightning bolt on and off. Here, we just demonstrated how to use it when it's off. Okay then, so we're done creating the mid surface. Let's go ahead and do this. Let's go ahead and quickly create the mesh. So we'll go to Surface Mesher. And here we are going to use a very large mesh size. We always want to start with a very small mesh size. We don't want to use a lot of elements yet. So here we only used a few. You don't want to do this right off the bat. I say this for the following reasons. This is still modestly small, so let's go ahead and use 100 millimeters. Right, you don't want to jump straight to a mesh like this. If you're new, it's better to use a very large element size like this. The reason is because you want to get a handle. You want to get used to various other operations before you jump to a very small element size mesh. So here, let's work with this. Let's go ahead and close this. Let's go ahead and hide this for now. Let's go ahead and show only the solid one. And actually, let's go ahead and create a new part. So right click on Model 6, add part, select solid 1 and move it to this new part. And here, let's go ahead and expand that branch. And over the text, click one time with the mouse. Click another time if it doesn't work. And now I can rename that. So we'll rename it part 2. And now hide this solid. And let's go ahead and just show this general body. So now we need to apply a material, a thickness, loads, and constraint to this surface geometry. So here on the bottom right, there's a sphere icon. Click that, it opens this material window. Click on create material. This is where we are going to use this tool to create a material. So let's go ahead and assign a Poisson's ratio and then a density. And now we're done with the material. Now click on this option, 2D element properties. Now while creating the mid surfaces, it automatically created these two properties. If you look here on the left side of the model browser, open the 2D element properties branch. There are already thickness definitions defined for this geometry. Right click on this and click on unassign and do it again for this. And then here, let me reopen the 2D element properties and right click on this. What I want to do is delete this if I can. Okay, perfect. I don't want this to confuse me with what I'm going to do. Now, click on create 2D element property to create a new thickness definition. Here, let's go ahead and supply 10 millimeters. Now, where did I get the 10 millimeters? If we open or turn on the solid geometry and click the distance tool, I go from edge to edge, and I believe that's 10 millimeters. Oh, it's 50 millimeters, sorry. So here it says 50 millimeters, so let me exit the measure tool. And here in the left, or the right rather, I'm going to type in 50 millimeters for the default thickness. Now, what about the material? The shell is going to depend on this material that we defined a moment ago. Now, let's go ahead and hide the solid geometry. Let's click on assign 2D property. I'm saying, hey, take that thickness and material that you defined a moment ago and assign it to this geometry. And here I get a prompt saying that, hey, you've already defined a material and thickness here before. And here it's asking, do you want to replace the old definition? And I say, yes, continue. And now I've already assigned the thickness to this geometry. And here I get a warning that there are some elements. Let's go and look here. Okay, this might be a problem, so let's see. Okay. So let me do this. under the fields branch, expand that. Let's go ahead and just delete that. That's why I'm getting this error here. Let's go ahead and see if that works. Okay, so before there was a warning here saying that, hey, the thickness was dependent on this field. I deleted the fields. Now that warning is gone. If you want to confirm that the thickness has been defined properly, turn on the mesh. And then here in this top set of tools, click on this icon called shell thickness. Click on this option, 3D thickness and offset. And now this gives you an idea of what the thickness looks like for each element. So here we notice that every element has the thickness. This looks good. So now we can turn that off and we can continue working with our model. Let's go ahead and define some boundary conditions. So if we go to loads and constraints, let's click on constraint. Let's click on this clamped option here. You'll notice that all the checkboxes are marked. So this is going to impose restrictions on the first, second, third, fourth, fifth, and 6th degrees of freedom, a clamp condition. Here, the lightning bolt is on. So anytime you click on an object on the screen, it automatically creates the constraint. Now you can go one by one. This is something you can do. Or you can disable that. So let's go ahead and disable that. And what you need to do is select the shift key. Click the shift key and hold the shift key. Now you can select multiple edges. So that's what I'm doing now. I've selected 4 edges, and if you zoom in, you notice that they are orange, or rather the edges are orange, indicating that I've selected those edges. Now the lightning bolt is off, so it doesn't automatically execute the action. Click the middle mouse button, the scroll wheel, or MMB, and now it performs the action, and now it's created my constraint. Exit this. Let's go ahead and create the pressure load. So click on pressure. Let's go ahead and say the pressure is 100. And now hold the shift key and then select these multiple faces. Let go of the shift key, and now it goes and applies the pressure load, if you will. Now we're almost done with this. Let's go to the model browser here on the left, right click on the part and click on place in analysis scene. Now we're almost ready to perform the analysis. Do not click the run icon. Click on export BDF. Here, select the units that you want. Let's go ahead and output this to the downloads directory. We'll go ahead and call it model. Click export. And here at the bottom left, it says exported this BDF file. So let's go ahead and navigate to that BDF file and open it here in the bulk data file. You notice one thing here. I don't have a subcase defined yet. So let's go ahead and see what's going on here. If you go to the study tab, we do not have a subcase or analysis configured. I believe what you need to do first is click on this button, generate a simulation scenario. And you notice now it's gone ahead and created it. Let's go ahead and click on export BDF. Let's browse again. Replace that. Export. Let's wait for this message. Exported BDF. Let's open the text file. And here, let me go ahead and turn off one option. So okay, so it's been updated. Okay, now we have the following. The case control section has one subcase defined. It's a load case. So let's briefly go over what's in this bulk data file. We have all the elements, all the nodes. We have the material, the thickness of the walls, the pressure load, and our constraints. We'll talk about the constraints in a moment. What this head of the file is stating is the following. Hey Nastran, perform a solution 101 or a linear statics analysis. Output the displacements, the stress, and the SPC forces. Perform the statics analysis for subcase 1. Consider load 1 and SPC 5. Load equals 1 is a pointer. Load equals 1 is a pointer to P load for 1. So these P load entries. SPC equals 5 is a pointer. Go to entry 5, which would be this entry. And now, this is only considering one SPC1. So if we go to loads and constraints, click on load case 1 and click on SPC, and you notice that we have 5 SPC conditions, 5 clamps if you will. So here on this edge of the model, we have clamp 1, clamp 2, clamp 3, clamp 4 for the 4 edges. And then for the other edge, we selected all the edges together and it created the 5th clamp. But we want to consider all of these clamps together. So click cancel here. Go to loads and constraints. Click on constraint combination. Here on the bottom right, mark all the checkboxes. This is saying, hey, create a group of constraints, but consider all the constraints that we define. Click on the green checkbox. And then if you go back to the model browser, the model tab, if you expand the constraints, you now have the 5 clamps and this new option, constraint combination 1. So let's go ahead and see if you can turn that on. Actually, you cannot display that, which is okay. Go back to the study tab. Double click on loads and constraints and initial conditions. Here on SPC1, let's go ahead and select this constraint combination 1, click OK. And now let's go ahead and export that bulk data file. So we'll go ahead and click on Browse, Model BDF, yes, replace, export. Okay, so now SPC equals 5, that's a pointer. It's pointing to SPC. Actually, this is not correct. So let's go ahead and look at this again. SPC equals 6. Okay. So I think I know what's going on. So I think I assigned it to the scenario 1. That's not what we want. So let's go ahead and deselect this checkbox. Click apply. Go to load case 1. That was my mistake. I should have selected load case 1. Open the constraints branch. Mark or select this constraint combination 1. Make sure this radio button is selected. Click apply and OK. Export the bulk data file again. And click export. And if we go back here, now it's equal to SPC equals 6. Before it was set to 5, which is not what I wanted. I wanted 6. So now this is pointing to SPC 6. So if you go down, it points to SPC at 6. It includes SPC 1, 2, 3, 4, and 5. And then here we have the SPC entries. So here, if you look at this field, SPC 1, 2, 3, 4, and 5 is saying, hey, fix these nodes for the degrees of freedom 1, 2, 3, 4, 5, and 6. Okay, perfect. So now what we can do is we can double click on Nastran, click that bulk data file, click run. And we'll go ahead and give this a few moments. One thing about the command prompt, when you click anything on the screen, it pauses the program. It says select MSC Nastran. When it says select, that means you've paused the program. So I believe you want to unpause it. I believe you press enter. Right. So once you press enter, it removes select and it allows the program to continue. So that's where we're at right now. If you open the directory, you actually get a F06 file. So let's open that in Notepad. Let's go to the very bottom and see if we get this. If you get this information, external work, this is evidence that you've performed the statics analysis. Also, look for any user fatal messages. This is indication there's an error with this problem or this model. Here I've performed the search. There are no errors. And now what I can do is I can look at results. If you want to attach the H5 file that was created, I believe you can do this. Right click on scenario 1, click attach Nastran results, go to browse, select that H5 file, and click attach. Now, I skipped the use of the running man icon. Now, the reason I skipped the use of the running man icon, do not click on this. I was struggling with that option today. This might be because of the version I'm using. Maybe there is a small issue with that. So what we did is we used a Nastran manually to run the statics analysis. You notice that the post-process button is now enabled. Click on that, and this is going to open a post-processing mode where you can look at the deformations or the stresses in this model. So let's go ahead and look at that real quick. Okay, so now we're looking at the deformed shape. If you want to, you can go ahead and turn off the deformed shape with this button at the bottom center. So this is the deformed shape when it's on, and then off. If you want to, here on the right, there's a fringe button. Click on the fringe button. This will open a color plot, if you will, where you can look at quantities like the displacements or stresses. So let's go to move this. Right now we're looking at the stresses. Let's go and look at the displacements. And then if you want to turn on some labels, you can click on this hotspots display. So this is telling you where the highest regions are, or highest and the smallest. Okay, so you notice that whenever I hover over the model, it's just flickering. It's highlighting everything. Right click on the screen. This is the picking option. Right now it's currently set to highlight any bodies. But what you can do is click on this option. Maybe highlight only element faces. So now when I hover over the model, it's not highlighting the whole body. It's only highlighting one element at a time. So this helps prevent that flickering that you might see. Okay, then we're done with the 2D element option. Let's now mesh this with 3D elements. So what we're going to do is go to the following. Let's go ahead and show part 2. Let's go ahead and hide. Or let's do this. Go to part 2, right click on that. Click on show only. So this deselects all the other checkboxes, but apparently not the constraints. So let's go ahead and right click the constraints. Let's turn off everything there. And now let's mesh this with 3D elements. Remember, you do not want to mesh this with tetrahedrals. That's the #1 way to look like a beginner, a rookie, essentially. So what I recommend doing is the following. Click on 2.5D mesh. And then here, let's go ahead and see if we can get a mesh out of this. One quick comment. Let's go back to part 1, actually. I forgot to mention something. Once you're comfortable with the whole procedure, you can now use a finer mesh. So let's go to the surface mesher rather. Let's go ahead and use maybe 500 millimeters. Okay, let's close this. Let's go to study. Let's go ahead and export this. We'll call this model B. Export. And let's go ahead and open this side by side. Okay, so on the left is the original model and on the right is the new model. You'll notice that the head of the file is still the same. Perform a SOL 101 or statics analysis, output displacement stresses, perform this for subcase 1, SPC equals 6 and load equals 1. But you'll notice that there are more elements now. There are more nodes, and then after this, the material, the P shell, everything's the same. There are more payload 4 entries since there are more elements. And now let's go ahead and run this with Nastran just to make sure it runs properly. So this is model B. And then we'll get a F06 file here in a moment. So the first run, if you will, was just to perform the statics analysis for a test mesh, if you will. Once we got everything to work, then we increased the number of the elements. So now if I look at this, if I look at the external work, I do get external work. This is evidence that we performed the statics analysis. Let's look for user fatal message. Let's look for any errors. Okay, there are no errors. This was a successful analysis. I can go back here. I can go ahead and right click, attach Nastran results, select that H5 file and look at the displacements and stresses. So again, start small, then go big later on. Let's go to model and now move on to the next example, which is hex elements. So let's go ahead and turn off. Let me go ahead and turn off all of these constraints. And let's go ahead and focus on the mesh for this. So remember, you don't want to mesh this with tetrahedral elements. That's the wrong way of doing it. So I think a moment ago we were using something like this. Let's go ahead and show you what the bad mesh looks like. So here, evidence of the bad mesh is these elements are very distorted. So this is not okay. What we're going to do is the following. Let's go ahead and turn on the 2.5D mesher. And let's go ahead and decrease the element size to maybe 100. Okay, this is still not okay. One thing you can do is you can use mesh seeds. So let's go ahead and try that. Let's use all these 3 elements through the thickness. So let me click on this edge. So this is something a little better. Let me undo this actually. Let me select the other edge. Okay, now why did it work for this edge and not the other edge? Let me make sure this is working here. Oh, okay, you know what? Let me formally do this with cells. So let me exit this and delete this old mesh. So when you're creating a hexahedral mesh, it sometimes helps to create what are called cells. So let me go and jump to the split tool. Let me select this first option, which is the split using a plane. Let me select this body. Click the middle mouse button, and now it turns magenta, I believe. Click one of the faces, and now it turns orange. Now we get a white outline of what the cutting or splitting plane is. Click the middle mouse button again to perform the split. And now if we look carefully, we have these dotted lines. Let's go back to the hex mesher. So solid mesh, click on this 2.5D option here and select this body now. And then let's go ahead and create some seeds. And let's see if I can get this to work. So we'll create 3 elements here. Okay, now I get 3 elements along all the faces, if you will. So you notice we get 3 elements here, here, and here, which is what I wanted. But now what about this? Let's go ahead and create 3 elements through this stiffener. And that still didn't work. So let's create 3 elements here. And this is a little better. We might need to create more splits. So let's go ahead and delete this. Let's go back to geometry, edit, and the split tool. Let's go ahead and click on this. Click this face and the opposing face. And let's look at this. Okay, that looks a little better. Let's click this. And here, let me show you what the outcome of this action is. So if I go back to the mesher, let's go ahead and use 3 elements through the thickness here. Let's click this edge. And now I get 3 elements through the thickness for this one stiffener. So that's what I want. So let's go ahead and keep creating those splits. So here we'll go ahead and enter the split tool. We'll click this body, click MMB, click this face, click MMB again, and this goes ahead and creates my next split. Let's go ahead and do this for the other side. Click the body, rotate this, click this face, turns orange, click MMB again, and it creates the next split. Let's go ahead and move on to the third stiffener. Click this body, click this face, click MMB again, and then we create the next split and then the final split. Let's go ahead and click this face, click MMB, and now we have our final split. Click and exit the tool, and now we have all the splits that we need. Let's go to meshing, solid mesher. Now, what these dotted lines are, they've partitioned the body into multiple cells. So here in the vertical set of tools, click on cells. So this is cell 1. You can mesh that. Cell 2, cell 3, cell 4, and so on and so on. So we partitioned this one solid geometry into multiple cells. So let's go ahead and undo all of this. Let's select the body tool so we can select the entire body. And now let's go ahead and work on the mesh seeds. So I believe we need to create 3 mesh seeds here. So let's go ahead and do that here. So 3, 3. So we need to tell the mesher, hey, use at least 3 elements for the thicknesses, or use 3 elements for these edges. So that's what we're doing right now. Okay, now let's use 3 elements for these stiffeners. Okay, perfect. And we'll go here. And let's go ahead and look at the other side just to make sure everything looks okay. Okay, everything does look okay. Okay, perfect. So we're done with the mesh, so we can hide that. So right click on the mesh and hide it. Now let's go ahead and work on some loads and boundary conditions. So we'll go to the material, or sorry, we'll go to loads and constraints. So let's go ahead and create a clamp constraint. So here, let's go ahead and right click and hold the shift key. Now, right now, it sometimes will select objects through the solid. So what do I mean by this? Sometimes when you select objects, so right now we want to select this top face as an example, but you notice it's selecting the edge through the object. So it's actually trying to select this edge in the back. We don't want that. We want to select what's visible to us. So here you click on this visibility picking option. This, for the most part, will only pick options that are immediately visible. But here you'll see that it's still not honoring this option. What you can do is click on this other option, faces. So this is only going to select faces that you see on the screen. So click and hold the shift key and click on these faces. So face 1, face 2, face 3, face 4, face 5, face 6, and our last face. Let go of the shift key, click the middle mouse button. And now if I turn on the loads, I should have a new, or actually I've incorrectly created a, I've accidentally confused my options here. I was selecting faces for the load when I'm creating the constraints. So let's redo this real quick. So we'll select this face, this face, this face, and all these other faces. We'll click the middle mouse button. Let's go and rotate. And if we want, we can turn on that constraint. That's what that looks like. It's going to repeat this process for the other side. So let's zoom in, and we'll select these 4 here. and we'll repeat the operation for the other sides or faces. So let's go ahead and select these. Let go of the shift key. These are the faces for the clamp, and then we'll click the middle mouse button, and now we have our new constraint 8. Now let's go ahead and move on to the pressure load. So like before, let's go ahead and supply a pressure value, and let's select these top faces. So hold the shift key and select these faces. And now if I close this, I should have a pressure load somewhere here. So let's turn that on. Okay, perfect. So this is what the pressure looks like. You notice that the pressure is in this direction. From the first analysis with 2D elements, the pressure was actually going in the opposing direction, if you will. So if you want to flip the direction, all you need to do is use a negative sign. So let's go ahead and use negative 100 and click this green checkbox. And you'll notice that the pressure load is going the other direction. So if we look at the arrows, and they're going in the reverse direction, if you will. Okay then. So we're done with the constraints and the pressure. Now there's one thing I forgot, but I'll get to that in a moment. Let's go to part 2 and right click that, place an analysis scene. There are 2 things that we forgot here. We need to create a group of the constraints. So here on the right hand side, click on constraint combination. Here, this combination is going to include constraints 7 and 8. Click the green checkbox. And let's go ahead and hide the pressure. So we have a constraint on the left and a constraint on the right. So constraint on the left and constraint on the right. We created constraint combination 2, I believe, that considers constraints 7 and 8. We've loaded this part into the analysis scene. And if you want to create a new scenario, click on this button here. You'll notice that for a mechanical system, I have part 2 loaded, which includes this hexahedral mesh. It's currently set to linear statics. Click on this option, generate a simulation scenario. This is going to create a new scenario. So now let's go ahead and look at loads and constraints. Click on load case 1. For constraints SPC, let's go ahead and make sure we've selected constraints combination group 2. And for the loads, let's go ahead and make sure we've selected that pressure load we had a moment ago. Okay. And now click OK. Double click that. And let's make sure we've assigned, let's make sure we've selected the correct options. Sometimes what happens is you'll make the modification, you'll exit the tool, and then it doesn't honor your selection. So let's go ahead and confirm this. Did it confirm the selection of this group? Yes. Did it confirm the selection of this load? Yes. Okay, perfect. We can continue on. Now, instead of running this with the running man icon, just to export the mesh, we're not going to work with the built-in solvers. So here we'll call this model C hex mesh. Click export. Export it model. Let's go ahead and minimize this. Let's go ahead and open Nastran and run this. Okay, so it's running in the background. Let's open the bulk data file for a quick moment. So here on the right is that new bulk data file. Here, let's look at this. SOL 101, linear statics, output the displacement stress and SPC forces. Do this for load case or subcase 1. We are now dealing with hexahedral elements. Here, if you look down, we have the nodes, we have the load conditions, and so on and so on. You know, I don't expect this to run for one reason. I don't have a material. At least I don't think I have a material. So let's open the F06 file. Let's look for user fatal message. And now I get these errors. No property entry for element type hexa, undefined coordinate system. So let's go ahead and see if we can fix this. Surprisingly, there's no material for this. So that's because I forgot to assign a material to these elements. So to assign a material, here on the bottom right, click on this option, 3D element properties. Create 3D element property. Here for the material ID, let's go ahead and select that one material we made a moment ago. Click assign material. Click this body. And here in the bottom left, it says assign 3D element property to part 2. Click and exit this tool, turn off this window. Let's go ahead and do the following. If we go back to the bulk data file, let's look for a mat1 entry. There's no mat1 entry. If you go back to one of the older bulk data files, there is a mat1 in the older bulk data file with 2D elements. We've defined a material here, but there is no mat1 entry in this new file. So what we're going to do is export this, and let me rename this. Let me rename it model D. Click export. So in model C, there is no mat1. So I search and there's no mat1. Let's open this new bulk data file, model D, and let's look for mat1. Now I have a material in this version of the file. So what I can do is I can open Nastran and open and run that bulk data file with Nastran. Let's open the F06 file that we get in a moment. And let's look for any errors in this example. So user fatal. There are no errors. Now, do we get external work? Let me go ahead and see if I can find this. Was I looking in the right file? So external. Okay, let's see if we can get. Okay, perfect. So I do get that option. So I do see some external work. That means that the deformation analysis has been performed. This is good for us. Now what I can do, I can go to that scenario, right click on that scenario, click attach Nastran results, go to browse, go to here we're working with model D, click attach. Now, once it's attached the bulk data, or rather the H5 file, we get this message, attach Nastran results successfully. Click on this post-process icon. And now I can look at the deformations or the stresses for this model. So here, since we already performed a different scenario, a different analysis, it opens 2 windows. But maybe I don't want this, so let's go ahead and see if we can figure out how to turn off the old window. Okay, so here, let's go ahead and turn this off. So on the left is that first scenario where we ran an analysis with 2D elements. And then on the right is the analysis with 3D elements. So let's go ahead and jump to that. Instead of turning these off, maybe we'll leave them on for a quick moment. On the right, let's turn on the fringe plot. Let's turn on maybe the von Mises stresses. And then here, let's go ahead and turn on maybe some hotspot markers. And back on the left, let's do the same thing. Let's turn on the hotspot markers. Now for the von Mises stresses, I think we should get something similar. Let's go ahead and open this. Let's change this to stresses. And right now we're looking at the von Mises stresses for one side of the thickness. Let's look at the bottom. So let's go ahead and close this. So here we get an idea of where the highest von Mises stress is. It's telling me it's here. Now you should get something similar when you use 3D elements. You wouldn't necessarily get the same values, but you should get something similar. Okay then. So now that we have these two windows, how do you do just show one window? Here in the top right, I believe it would be this option. If you click on this, let's go ahead and see this. Can I turn this off? No. Let's go ahead and maybe use maximize. Okay. So now we're looking at scenario 1. I think if you right click on scenario 2. Okay, let's go ahead and see if we can jump between the different windows. Again, I use Apex very rarely. Oh, here in the bottom left, we get these view tabs. We're looking at scenario 1, load case 1. Click on this other tab, view 3. And now I'm looking at a different scenario, scenario 2, load case 1. Okay then, so that's how you look at results when you look at 3D elements. Let's go ahead and close this. So we're almost done with this video. There's one last thing I want to leave you off with. This next part of the video is regarding the most common error you would get as a new user. So let's go ahead and go back to the model. Or actually, let's go back to study. Let's suppose that I did this. Let's go ahead and modify constraint 7. Let's see if we can modify it actually. Okay, so let's go ahead and create a new constraint actually. So let's go ahead and hide the old constraint 7 and 8. And let's go ahead and create a pin constraint. So let's go ahead and do this. Click on general constraint and let's go ahead and fix translations only for the X and the Y. And we'll forget about the Z for a moment. Let's go ahead and also disable the rotations and let's pick these 6 faces. So let's go ahead and rotate this a little. Zoom in. Select this face, these faces. Now, the most common issue is that you've defined constraints, but you do not define enough constraints to satisfy the equilibrium equations. Remember, you want to make sure that the sum of the forces in the X, the Y, the Z, they're all 0. The sum of the moments about all X, Y, and Z are also 0. But if you don't define enough constraints, these equilibrium conditions are not going to be satisfied. So right now, I define constraints for the X translation, which would be this direction. I define constraints for the Y direction, which would be up and down. I've also defined constraints for the rotations, but there's nothing in the Z direction. So that's going to be a problem for us, as you see in a moment. So now let's go back to study. And we're going to modify scenario 2. Let's go ahead and open loads and constraints. Let's open load case 1, open SBC 1, and select constraint 9 and click OK. Let's go ahead and output a bulk data file. We'll call this model E. And we'll call it not in equilibrium. So we'll export that. And let's go ahead and open Nastran and run a model E. Now, we should expect it to fail because the model doesn't have enough constraints for equilibrium. When you open the F06 file, you're going to get the most common fatal message. User fatal message 9050, I think it's called, but I think it's been renamed in newer versions of Nastran. So let's go ahead and look at this. So if you look towards the bottom, see if I can find it. User fatal. We actually don't get a fatal, which is interesting. Let's go and look at the work. Okay, we actually do get work, which is surprising. I was expecting this to fail. So let's go ahead and open the head of the file. SPC equals 9, so let's follow that. So if we go to the bottom of the file, okay, so it didn't honor my request. So let's go ahead and open this. So if you remember, I mentioned always make sure that you confirm that the proper selections have been set. So right now you see that's, even though I selected number 10, it didn't honor the selection. So here, let me select 10, click apply, click OK. It's close the window, open loads and constraints again. Let's go to SPC, and now it's confirmed that I've selected 10. So let's go ahead and output the bulk data file again. And let me do this. Let me copy this subcase 1. And let me export this. So you notice a moment ago, it was set to SPC equals 9, which was the correct configuration of the constraints, but I want it to equal SPC equals 10, which is the incorrect definition. So that's been done. Let's go to Nastran and rerun this. And now I expect it to have an error message. Let's just go ahead and keep it. Let's go ahead and wait for this to finish. And then we should expect the fatal message in that F06 file. Now this might take a little bit longer because there are more elements in the model, so it takes longer to finish. Let's go ahead and look for fatal. Okay, now we get this message. This is going to be the most common user fatal message that you find. In older versions of Nastran, it's called user fatal message 9050. So here, what do we have? We've defined, so sigma for the, here, let's go ahead and look at that actually. So remember, you want to make sure you've defined enough constraints to satisfy the equilibrium equations. So you want to make sure that the sum of the forces in the x, the y, and the z, they're all equal to 0. And the same for the moments. So remember that if we look at the constraint that we defined, let's go ahead and look at that constraint for a quick moment. So that would be this constraint. We've constrained degrees of freedom 1, 2, 4, 5, and 6. So, and this is one constraint, but there's a problem. What about degree of freedom 3? So we have constraints for the 1, the 2, and not the 3, but we have constraints for rotations, so 4, 5, and 6. So what about DOF3, which is the Z component, if you will, of the constraint? So you'll find out this model is actually free to translate along the Z direction. Let me see if I get a H5 file. I don't know if this will work, but let's see if this works. Let me save my model here. Here, let's go ahead and right-click Scenario 2 and attach Nastran results. Sometimes what happens in newer versions of Nastran, it will switch to a different type of analysis if it detects this error. It switches to a normal modes analysis. So it's attached results. Let's go ahead and look at the results if we can see them. So this, instead of performing statics analysis, it encounters the error. So because it encountered the error, it then defaults to a different type of analysis, which is called a normal modes analysis. So here, let's go ahead and look at that normal modes analysis. And I really do not like this multi-window view. Let's go ahead and look at single view, view 3. So now let's go ahead and animate this and see if we can animate it. Okay, so here we get what this looks like. So it's up to you to look at the mode shape that we get at the end and ask yourself, okay, this is telling me which direction is not constrained. And right now it's telling me, okay, it's allowed to rotate about the y-axis. What's going on here? This makes sense. We don't have constraint along the z-axis. So this model can either translate along the z-axis or it can rotate about the y-axis. So this is a way to detect which direction is not properly constrained. Here, normally, you would get a different mode shape. Oh, interesting. Okay. So here, normally or traditionally, you would get multiple vertical bars here, one for each mode shape, but we don't get that. What I have to do, let's see if I switch to view. Perfect. So here, okay, I know what's going on. Here, we're looking at this frequency. So if I look, oh boy, this is not right. So what's going on here, all the modes have a natural frequency of 0. I don't know if we could look at that table actually. Let me see. I think it's here. So here in the bar, the right hand side, there's this button called data grid. Here, there would be a modes table. If you look at the modes, the natural frequencies are 0. If the mode has a natural frequency of 0 hertz, that's a rigid body mode. That means that there is motion without deformation. It's rigid. It's a rigid body mode. So here, if we flip through the 3 modes, mode 3 is the biggest evidence that the third degree of freedom is not constrained. You see it's able to translate. So let's exit this. Let's do the following. And I'm running out of space. So let me do this. Let me go ahead and save this. And one option that you have to free up space is the following. Right click on the old scenario and you can either detach the results and then you could delete the old H5 file. So let's do this. You could delete the result files or you can just empty the recycling bin like I am doing. That should free up some space. Now, what was I going to do? Right, I was going to define a constraint for the third degree of freedom. So let's go to constraint. Let's go ahead and define a constraint for the z direction. And let's go ahead and select these faces. Now, I have a lot of data in the way, so you could turn off the boundary conditions, and I believe you can also turn off the mesh. So let's go ahead and see if you could turn that off. I guess I can't. Let's see if I can turn these off. All right, they were just in the way, and I didn't want that. So we'll select these 3 faces, so that, like this face, this face, and this face. Let's go ahead and see this. Another thing, I'm running this operating system on a virtual machine, so I think I have like 2 gigabytes of memory and 2 cores, and the graphics device is being emulated. So this will run a lot slower than if you were running physical hardware. So that's why these operations are going to run a little slower. So let's go ahead and make sure I've selected all these faces. Click the middle mouse button. And now, since I've turned off the markers for the boundary conditions, I need to turn those back on. Let's go ahead and exit this for a moment. Let's go back to the model tab. So now, constraint 9 constraints 5 degrees of freedom. So let me go ahead and deselect that. So this is constraint 9. So again, this constraints 5 degrees of freedom. this constraint is allowing motion in the z direction. But then I created a new constraint, constraint 10. This constraint only constrains motion along the z direction. So now that I've constrained all 6 degrees of freedom, it should be able to run successfully. Now, let's go ahead and modify constraint group here. So here what I've done, I double click this group. What you can do is you can click properties and it'll open this constraint combination. We're going to modify this. We're going to say, oh, what's going on? We're going to say, you know what? Consider constraints 10 and 11. So constraint 10 is considering 5 degrees of freedom, and constraint 11 is considering 1 degree of freedom, which is the z direction. Click on the green checkbox, exit this, and now, like before, let's go ahead and make sure this is correct. Reopen that dialog. Make sure that constraints 10 and 11 are selected here. Exit this. Go back to the study tab. Go to scenario 2, load case 1. So scenario 2, load case 1. Open the SPC branch. Make sure you've selected constraint combination 2, which includes constraints 10 and 11 here. Click apply and OK. Now again, confirm the selection. Scenario 2, load case 1. Make sure that constraint combination 2 was selected. Okay, things look okay here. Now what I can do is I can export a new bulk data file. Let's go and rename this. Let's call it model F. Export. Click save. Export. And now I have a new bulk data file. Let's go ahead and run this with Nastran. And now that I have a new SPC, let's go ahead and look at that new SPC actually. Go ahead and open this. Find the SPC, which would be this one. Or actually, okay, yeah. So this is the additional SPC that we built. So you notice that this is only constraining the 3rd degree of freedom, or the z direction. So now we've constrained all the degrees of freedom. We could do this by hand, and that's usually the recommendation. Get a piece of paper, draw your finite element model, roughly write out your loads, roughly draw out your constraints, hand write the equilibrium equations. Do you have enough to constrain all 6 degrees of freedom? And then here, let's go ahead and open the F06 file. Let's go ahead and look for user fatal message. So you can see that there are no user fatal messages in this F06 file. Let's go ahead and look for external work. Again, if you get external work, that's evidence that the deformation analysis has been performed. And here we get a positive external work. Perfect. Let's go ahead and right click on that and attach the Nastran results. So model F, attach. Okay, overwrite the old results. And then click on the post-processing icon. And we should get our deformation results in a moment. Now we'll probably get 2 windows like we did before. Let's go ahead and disable the 2 window view. Or actually, we get 1 window now because I've unattached the results from the first scenario. And right now I notice that my virtual machine is running a little slow. That's because all these arrows are displayed. I believe if you turn it off, it should run faster, and it does. Okay, let's turn on the fringe plot. So this is what the von Mises stresses look like. I can go ahead and look at the hotspot. One thing I recommend, let's see if it's supported here. I recommend turning off averaging. Okay, so it still performed the averaging. what averaging does, it modifies the values that you get from Nastran, which can kind of cause confusion here. This is what that looks like. A few other things. If you want to make sure that you've supplied enough boundary conditions, or enough constraints rather, you can perform a normal modes analysis. So here, let's go ahead and do that. Let's go back to the model tab. Let's go ahead and do this. Let's go ahead and save this. Click on part 2, place an analysis scene. Select normal modes analysis. Click on this icon, generate a simulation scenario. So now we have scenario 3, which is dedicated to normal modes analysis. Normal modes analysis is used in a dynamic scenario, but it can also be used to confirm you have enough constraints for the equilibrium equations. So here for loads and constraints, let's go ahead and do this. Let's make sure that we've assigned only the bad constraints. So that would be this one, constraint 9 with ID 10. Click OK. Now open that dialog again. Let's make sure we have selected those constraints. Okay, we've selected ID 10, constraint 9. Let's now export the bulk data file. Let's go ahead and call this model G modes. Export. And now let's go ahead and run Nastran for this. And now let's create a different scenario. So this first normal modes analysis is with the bad constraints. So we should get modes with a natural frequency of 0. What I'm going to do is I'm going to create a new scenario that is for normal modes. Let's go ahead and click on generate simulation scenario. So now we get a scenario 4. And in this scenario, we're going to add the correct boundary conditions. So we constrain all 6 degrees of freedom. So here, let's open loads and constraints for scenario 4. Let's go to load case 1. It's technically not a load case since this is a natural frequency analysis. Okay, so here we're going to create, in the previous scenario 3, we've only selected the bad constraint, but now we're going to select the constraint group. This group, if you remember, includes constraints 9 and 10, which are the good constraints. So let's go ahead and click OK here. Let's reopen this and make sure we've selected that group. Okay, so now I can go ahead and output the bulk data file. So we're going to call this H modes, and we'll call this the OK version or the good version. And then let's go ahead and open and run Nastran. So I should have, okay, so let's look at model G, which again is the bad one. Let's look at, I think it's the real eigenvalue table. So if you look here at the natural frequencies for each mode, if you look at the cycles column, this gives you the natural frequency in hertz for each mode shape. You notice that the first 4 modes have a natural frequency of near 0 hertz. These are the rigid body modes, if you will. But then after that, we get 1.6 hertz, 2.5 hertz. These are non-zero natural frequencies. We're only interested in the first 4 in this case because they're near 0 or 0 hertz. These are the rigid body modes. Now, I believe we're done with the next natural frequency analysis or modes analysis. It honestly has a lot of names. And then I think we may have had an error. So let's go ahead and look for any fatals. Oh, I have run out of space. So let me do this. Let me save this. And let's go ahead and see if we can get some space here. So anything that's in H5 should be deleted. So I'm going to delete these here. Or actually, it might be better to delete some old Apex versions. Okay, so let me delete these old bulk data files, these old models, this recovery directory. Let me empty this, and then I think I should have space now. Let's go ahead and run the other Nastran analysis. So again, this is a virtual machine. I'm only running 2 gigabytes, 2 cores, and I think only 10 gigabytes of disk space. So I'm really, I really don't have a lot of resources for all of this. So let's look at the updated file. Okay, so now it's running, it's performing the natural or normal modes analysis. Let's look for any errors in this file. Okay, there are no errors, so let's go ahead and look for that real eigenvalue table. Okay, so before we were getting near 0 natural frequencies or 0 hertz, but after we use the correct constraints, we get non-zero hertz. Now notice that these are on the order of times 10 to the negative 1. Before, the natural frequencies were on the order of times 10 to negative 6. So these would be close to 0. They would be, what is it? 0.12345 hertz. But now the natural frequency is on the order of this. So these are near 0. Rigid body mode. This is I guess a normal, an okay mode, I'll call it. So now this is what we're going to do. We're going to attach both of those results here. So for scenario 3, which is the bad configuration, we're going to attach model G. And then for scenario 4, we're going to attach the good H5 file. So here, let's go ahead and attach those results. Model H and attach. And once we've attached both of those, the post-processing button here on the bottom right should be selectable. So we'll go ahead and click that. And now we'll compare the modes from both of those scenarios. So let's look at the left window. You've selected one of the windows when the border is orange. So right now we've selected scenario 4, load case 1, but what about scenario 2? Let's see if we can look at that. And for some reason, I don't have a model. Let's go ahead and see if we can determine why that is. So maybe it's because I need to show the part. So let's go ahead and see if we can show this. Oh, what's going on? Okay, so let's go ahead and see where we're at. So this is mode 2. Okay, what about this? Which one is this one? I'm trying to understand what's been selected here. That's okay, we don't. What we're going to do is the following. We're going to click the window on the left and turn on this table. So these are the correct modes, if you will, if I play them. Oh, this is, okay, I know what's going on. So this is the correct configuration for the constraints. You can see that nothing appears to be translating. Here, what we're going to do is jump between the modes. This is mode 2. You'll notice that there's nothing suggesting that there's translation. So this is mode 3. So this edge, if you will, these faces are constrained, and you can see the mode shapes reflect that constraint. What about scenario 3? Let's go ahead and see if we can right click on that and look at the results. Display in graphics window. I'm not a big fan of this side by side, just because you can see how confusing it is to operate it. Okay, now this is the problematic configuration. Let's look at what the modes look like here. So we're going to animate this. And remember, the third degree of freedom is not properly constrained. So you can see that we either have translation along the Z or we have rotation about the Y-axis. And here this mode is telling us, hey, you have rotation about the Y-axis. If we flip through a different mode, this one does a better job of telling you, hey, you don't have the Z degree of freedom constrained. And then if we go to the next mode, this also shows you that the third degree of freedom is not constrained properly. So let's go ahead and flip this and show you what that looks like. Right, so you can see that this face is not properly constrained. You can see it's actually allowed to have a rigid body mode about the x-axis is what it looks like. If we open the table, you notice that the natural frequencies are near 0 for these examples. So here we have times 10 to the negative 6 here. So there you have it. That's how you debug the most common problem when you're starting out with FEA. You saw how we could perform a normal modes analysis to help show what the rigid body modes are. This can clue us in on which degrees of freedom are not properly constrained. So to briefly recap the video, we started off with geometry for a thin wall structure. Instead of using 3D elements for the model, we used 2D elements. We created some mid-surfaces for the midplane of the walls. We meshed it, we applied the loads and constraints. We had, at the end, the displacements and the stresses for 2D elements. And then I showed you how to create hexahedral elements using the 3D solid geometry. We repeated the same process, loads, materials, and so on and so on. And then towards the end of the video, we discussed the issue with constraints. If you do not properly constrain your model, you get these user fatal messages, user fatal message 10,030 and 10,031. In older versions of Nastran, this is called user fatal message 9050. Here, what ends up happening, if you don't apply enough constraints, you don't have enough constraints to satisfy your equilibrium equations. We went through the use of a natural frequency analysis, where if you have natural frequencies that are close to 0, that's a rigid body mode. You don't have enough constraints. And then we created enough constraints, and then our natural frequencies are positive. They're non-zero, like in this case, model H. So we're pretty much at the end of the video. I think this year I'll start taking questions from new users. So if you're new to Nastran and you want to perform statics analysis or normal modes analysis, you're more than welcome to contact me at this email address, and I'll try and get back to you as soon as possible. So that's pretty much the end of the video.